Hi everybody, so good evening, not good evening, good morning. Okay, so what I'm going to do here is I will be spending 20 minutes, okay, in this session, and I will be solving some PYQs, right? So already we have discussed all the concepts, so we will take some PYQs, okay, and I will apply my own concept which I have explained you, right? So you have to see whether my approach is systematic way of solving the question, okay, and it is completely straightforward, right? You don't have to become circuitous or something, right? So you don't have to remember anything, just you have to apply blind approach to get the answer of any kind of questions, right? So I believe my voice and everything is fine. Okay, so let me check also whether my voice and everything is fine. Yeah, perfect. Okay, so let me take the very first question which was asked in the instrumentation branch again, right? So this question was asked in gate instrumentation this year, okay, in 2023, right? In 2023, and this is purely a PYQ session where I will take a couple of questions and I will discuss. Okay, so what question was there? The rank of the matrix A was 1, right? The question was the rank of the matrix A given below is 1. Okay. What is the meaning of rank of the matrix A given below is 1? The meaning is the number of pivots are 1, right? Keep in mind this, okay? As I told you that the number of pivots is equal to the rank of the matrix, okay? If you don't know what is the meaning of rank, forget about that, okay? I have told you how to find the number of pivots, okay, while applying elimination, right? So you can straight away find the number of pivots, and that is going to be the rank of the matrix. So you don't have to worry about anything. Straight away apply elimination with the help of elimination of any order of the matrix, okay, whatever order will be given. Then what you have to find out is you have to find out the ratio of alpha and beta. Okay, this question was very good. The ratio of alpha upon beta, right, is okay. So this question was there. The rank of the matrix A is given below is 1 and the ratio of alpha by beta is what? Okay, and you have to answer this question rounded up to nearest integer, right? So now the question is, what is the matrix given? So this is the matrix given. You see, this matrix is given as 3 by 2 matrix, okay? It is not a square matrix. 1, 4, minus 3, alpha and beta and 6, okay? So this is the matrix which is 3 by 2 matrix, okay? Means number of equations are 3 and number of equations are 3 and number of unknowns are 2, right? You see here alpha and beta, everything is 1, 4, minus 3, alpha, beta and 6. Now what is the ratio of alpha and beta? That you have to find out. Perfect, that you have to find out, okay? So how can you find out this ratio? So what you can do here is you can straight away blindly apply elimination, right? Okay, this question was this year only asked in instrumentation paper. Many students, what they do is they try to find the sub matrix, okay, they try to find the determinant and all, takes a lot of time, right? So here you can directly apply elimination. I'm just going to take this matrix, A matrix from here and apply elimination blindly, okay, by choosing the pivots. Now you can take this guy as pivot. 1 is here as a pivot, right? So let me take this guy as a pivot, okay? So 1 is here as a pivot, okay? Only I want one pivot, okay? One pivot in one column, right? I don't want any pivot anywhere, because one pivot means rank of the matrix is 1. In the question itself they have mentioned the hint, the rank of the matrix A given below is 1, right? You have to make these two rows what? You have to make these two rows 0, okay? So how can you make these two rows 0? See, this is 1, right? So you apply row operation. So on R2 you can apply row operation. So R2 means it will be R2, okay, and then you have to add it, right? So plus 3 times of R1, right? Because simply you just multiply by 3 here, okay, and then what you have to do, you have to multiply by 3 and just add it, okay. So R2 plus 3 R1, right? So it becomes 0, okay. And I believe this is fine for everybody, okay. Now if you want to make this guy 0 as well, okay, because beta cannot be make 0, right? Because beta is unknown, we don't know what is beta. So what you can do here is you can apply on R3 as well. On R3, what you will do on R3, just apply on R3, okay. So on R3, what you will do, you just multiply by you have to multiply by what? You have to multiply by 3 by 2, okay, because 3 by 2 into 4, so it becomes 2 means 6, yeah. So multiply by like on R3, okay, just you are applying operation on R3 and 3 by 2 times R1, right? Because you have to make this row 0 and this row 0, right? Okay, because you want only one pivot in this matrix, okay. So these are the operations which you have to apply. So simply applying these operations, so this become 1 and 4, simple. You don't have to change the first first row, and this will become 0. This is alpha plus, because this is what you have to add it, right? So you are multiplying by 3 means it becomes 12, so alpha plus 12, and this is what, this is beta minus beta minus 3 by 2, right? Beta minus 3 by 2, because you are multiplying by 3 by 2 and subtracting from the third row, and this becomes 0, okay. Now your life is simple, okay, because as we want number of pivots, or you can say the rank of the matrix should be equal to what? Rank of the matrix should be equal to 1 only. So this is the rank of the matrix 1. So these entries should be 0, okay. So these entries should be 0. So from here you can immediately say that alpha will be equal to minus 12, right? Alpha will be equal to what? Alpha is going to be minus 12, right? And the beta is going to be 3 by 2. Now what you have to find out, okay? Alpha by beta. So alpha is minus 12, beta is 3 into 2. Now you can say the answer for this question will be minus 8, okay. So if you know the concept, you can apply the concept, okay, and with the help of elimination, right? So elimination is one of the very powerful tool, okay, to solve any kind of question in linear algebra. Okay, so this question was asked in gate 2023 from my notes only, so that you have to keep in mind. Understood? So this was one question which you have to keep in mind. So simply what you have to do, always keep in mind, apply elimination. Whenever you want to find the rank of the matrix, or you want to claim about the kind of solutions you are going to get, right? So apply elimination, and whenever you have to get back the exact solution, or you can say the value of the variable unknown, then you go for back substitution as well, right? Depending upon the kind of solution you are going to get, right? Whether it is unique or infinitely many, right? So this was one question, very good question, okay. So I believe this is fine for everyone, okay. This question was very good question, okay. And already we have seen 2022 problem, right? That if any matrix is given, you have to claim whether that matrix has got unique solution or not, right? Or no solution, right? So suppose I take one question from gate 2022, right, from EC. Already we have seen this question, but let me again take. Consider a system of linear equation. The matrix is given like this, okay? 1 minus root 2, 3 minus 1 root 2, and this was 3, and the B matrix is also given. The B matrix is given as 1 and 3, okay? So these are the two matrices, okay. Now you can form the augmented matrix, simple, because this is non-square matrix, okay, and you can't find determinant and all in this case, okay. You can only find the determinant by making these sub matrices, right? Sub matrix, okay? Like by deleting some rows and column and just a square matrix out of this. This is a augmented matrix, right? And simply by looking at these entries, you can also claim that if you're going to add these two, okay, rows, then one row will be completely eliminated, right? So I mean for a matrix, okay. But let me augment here. So 1 minus 2 3 minus 1 root 2 minus 3, and this is 1 3. Now what you can do, you can choose the pivot. Why we are choosing pivot? Pivot is chosen to start with, you know, as you are starting the elimination process, you need one starting point. So this is one starting point, and now you have to make below all the entries 0. So you can say that this is going to be 1 minus root 2 3, and this guy should be 0 0 0, and this is 4, because you are simply adding here, okay. You are simply adding. You can say R2 में क्या कर रहे हैं, R2 plus R1, right? Okay, because 1 minus 1 means 1 minus 1 0, so everything is gonna be 0. So you see here, as I said that a right column has a pivot in this case. You see, right column has a pivot. If right column has a pivot, 0 something 0, okay, 0 equal to something is not possible, as everybody knows. So it is inconsistent. So blindly you can say that yes, if it is inconsistent, you will not get any solution. So you can say that no solution. Okay, no solution will be like this. Okay, so in the option there was option like unique solution for x, okay, infinitely many solutions for x, okay. In this case, unique solution we can't get. We cannot get unique solution. Okay, the very first comment which you can make. Why? Because number of, you can say number of equations, suppose m equations are there, number of equations are less than number of unknowns, you can say, right? Suppose m by n matrix is this, right? So number of equations are m, right? Number of rows are m, and number of columns are greater, right? So if number of columns are greater than number of rows, you will never get the unique solution, right? You will get what? You will get infinitely many solutions, or you can say you will get inconsistent solution, right? I mean no solution, okay, if it is inconsistent. So I believe this is fine for everyone. Next question is the question of you know, suppose we have got one question, very good question was asked, right, in GATE only. I'm gonna take that question as well. So this question was asked in GATE 2023 in aerospace engineering, right? What was the question? So the question was, the system of equations are given like x minus 2 y plus alpha g equal to 0, okay. So this time they have given ax equal to 0, means homogeneous system of linear equation. X minus 2y plus alpha g equal to 0, 2x plus y minus 4g equal to 0, and x minus y plus g equal to 0. So they have given this, and what they are asking, they are saying that this is the system of linear equation and it has non-trivial solution. Has non-trivial solution for alpha equal to. You have to find the value of alpha, and they are claiming that it has non-trivial solution. What is the meaning of non-trivial solution? Okay, what is the meaning of non-trivial solution? In the previous class, I have told you that, as you can see here, this is going to be the balanced system. Okay, balanced system means what? Number of equations are equal to number of unknown. It means you will get a square matrix, okay, out of this. Okay, so you can directly form the matrix A. The matrix A will be 1 minus 2 alpha, 2 1 minus 4, and this is going to be 1, and this is minus 1 and 1, right? This is the matrix you have got, and this is the square matrix, 3 by 3 matrix, right? Non-trivial solution means, I have already told you that if something is non-trivial, okay, it means it is not going to be obvious. Okay, trivial means obvious. Okay, so non-trivial means the determinant of the matrix should be equal to 0. Determinant of the matrix will be equal to 0. Okay, non-trivial solution. Okay, so what you have to simply find is whenever this kind of situation will be given, remember, and they are asking the non-trivial solution, they are saying that non-trivial solution, you simply find the determinant of the matrix. Okay, and determinant of the matrix will give you the value of the matrix, right? Simply. Okay, so there are various ways of finding determinants. I will tell you just expansion. Okay, just we will expand for the moment. Later when we will start matrix algebra, there I will discuss some of the shortcut as well. But I think if you know the long cut also, it is very helpful, right? So for 3 by 3 matrix you can directly find the determinant. Okay, so what you can do here is you can just equate so let me give you this. Okay, now you can find the determinant as it is non-trivial. See, if it is trivial solution, okay, so for trivial, okay, for trivial solution the det will not be equal to 0. For non-trivial, okay, the det should be equal to 0. Okay, so as we go ahead in the lectures, you will understand more and more about these concepts, right? So but for the sake of present, for the sake of understanding, just keep in mind for trivial solution, if the matrix is square matrix, so you can directly find the determinant. If determinant happens to be 0, then it is non-trivial. Sometimes we call, if determinant is equal to 0, means it is singular matrix. Okay, singular. And if the determinant is not equal to 0, means non-singular, we call it. Okay, non-singular. Okay, perfect. That you have to keep in mind. That is very, very important to remember. Okay, now because in the question they will give you these kind of equations and one unknown will be present. So how to determine that unknown is the main question. Okay, now the question is now how to find determinant. So you can take, see, this is plus, this is minus, this is, I think some you guys might be familiar with some of the basic how to find that. So just expand this. So we are just finding, okay, will be equal to 0. So 1 times 1, and this is minus 4 only, because, and this will be plus 2 times of 2 plus 4. Okay, I believe this is fine. Yes, perfect. Next is plus alpha times, just take remove this column and this row. So take the submatrix minor of the, okay, det of this, so minus 2, and this is minus 1, right? So simple. Okay, and you are equating to 0, so no problem is there. Now this is minus 3, this will be I believe 12, and this is minus 3 alpha equal to 0. Now you can take this guy that side. Okay, so it is 9, so minus 3 alpha equal to 9, right? I mean minus 9. Now you can say that alpha is going to be 3 from here. So it is very simple question. Okay, what was the question? So in recent year only, so whatever questions are coming from our notes only, right, from our concept, right? So you have to be very careful, you have to follow the session strictly. Okay, whenever it is uploaded on YouTube, okay, whenever right, perfect. So these are the questions, right, which I wanted to discuss, right? So apply elimination blindly. Okay, don't try to find submatrix and find the determinant of lower order matrix, then claim that yeah, the rank of the matrix is this. How to find rank of the matrix? I have told you, rank of the matrix can be found out by just by applying elimination, okay, and finding the number of pivots. Understood? So these are the questions, 3 questions, right? And in the next session I will talk about I will talk about the orthogonal concept of orthogonal, when two vectors can be considered as orthogonal, okay, and so on and so forth, right? Perfect. So I'm going to take one question here, you know, and I will explain completely, okay, then we will wind up the session. So quick question I will take. Suppose the question here is just for the understanding purpose. Now you can start PYQ. All PYQ you can solve based on system of linear equations, right? And find the number of pivots, find if they have mentioned rank along with the system of linear equation, then find the rank, because that if they have given you the rank means uh, by any means you have to just reduce that matrix to some standard echelon form, okay, row reduced echelon form you can say, and it is very simple then, right? Number of pivots you know already, right? So it is very easy, and depending upon number of pivots, rank of the matrix is less than the order of the matrix, then you will not get unique solution, right? That is what the main thing is. Okay, suppose we have got the matrix A. I mean, directly I am writing the augmented matrix, and it is very big matrix this time. So we have to solve the system of equations. Ax equal to b with 1, 2, minus 2, minus 1, 1, right? This time they have given very big, 2, 4, minus 4, 0. This is 3, and minus 1, minus 2, 3. Okay. And this is 3, this is 4, and this is 3, this is 6, minus 7. Okay, 1 and 1. And this is the matrix A, and now the matrix B is 1, 2, 3, and this beta. So depending upon this beta, we can claim many kind of situations, right? Because beta we don't know, so beta can be equal to 0, beta can be some value, okay, beta we don't know, right? So depending upon, while applying elimination, and in the end, okay, we can consider some cases, right? So you have to apply elimination, right? So you apply eliminations, right? You apply eliminations, okay? So after performing elimination, right? I'm not going to dictate here. After performing elimination, first of all, you can see here how many rows are there. 1, 2, 3, 4, and how many variables are there? There are many variables. So number of rows, okay, are less than number of variables. You will not get unique solution in this case. Okay, you can either get unique no solution, or you can get infinitely many solutions. Okay, so these two cases you have to keep in mind. So in this case, if the system is consistent, then you will get infinitely many. If it is inconsistent, then no solution. Okay. By looking at the system of linear equation only, you can claim these things. After performing elimination, what you have to do, you will get some special kind of a matrix, right? So what you have to do, how to apply elimination, everything you know, right? So you have to take this guy, okay, and apply some row operations. I have told you, okay. So after performing elimination, you will get some kind of a row reduced echelon form. So I'm just going to write directly, right? So augmented matrix becomes like this. Okay, so this is augmented matrix 1, 2, 1, 2, minus 2, right? Minus 1, 1. This is 0, this is 0. This time this is 1, 2, 5, and this has become 0, 0, 0. This is 2, 1, and this is 0, this is 0, this is 0, this is 0, and this is completely 0 now. And now this is 1, 4, 0, and this is beta plus 1. Yeah. So after applying elimination, after applying Okay, after performing elimination, right? So you have to apply some elementary operations. What are the elementary operations? You can either switch rows, so it will not affect your solution, or you can subtract two rows, two columns. Okay, so by multiplying, some scalar constant in any one of the equation and subtracting, so that you can delete some of the elements in the row or entire row, right? Okay, now the situation is what? The case number one. See, don't talk about unique solution in this case, please. Okay, don't talk about unique solution in this case. You see, this is the staircase. Okay, this is kind of a echelon form only we have got, right? Kind of echelon form, right? So here, this is one pivot. This cannot be taken as a pivot. This cannot be taken as a pivot, right? So this cannot be taken as a pivot. Okay, understood? This cannot be taken as a pivot here. This can be taken as a pivot. Okay, understood? This can be taken as a pivot. This can be taken as a pivot. But you see, suppose this is x1, this is x2, this is x3, this is x4, this is x5, right? 5 variables are there. So how many dependent variables are there? You can claim here, right? If solution will exist, but in this case, everything depends on beta here, because you see the matrix A has got one row 0, complete row is 0, right? One row is 0, but this beta plus 1 is not 0, right? So beta plus 1 equal to 0, sorry, does not equal to 0, and case number 2 is what? Beta plus 1 can be equal to 0. If beta plus 1 is not equal to minus 1, then the equations are inconsistent, okay, and you will get no solution. In the exam, they might ask you what is the value of beta, which is not equal to 1, right? Minus 1, then you will get no solution. For no solution, what is the condition on beta, right? And for infinitely many solutions, this is the condition, right? So this will become 0. So one row is completely 0. So you can say consistent, and you will get infinitely many solutions. Infinitely many solutions. One more thing I would like to mention here is that if you want to find number of free variables, you see the column which does not have pivot is the free variable. You see x1, this column has a pivot, so you say this is not a free variable. Here this is a free variable and this is a free variable. Okay, so in this case you can say that x2 and x5 are the free variables. Free variable, and x1, x3 and x4 are the dependent variables. So you have to take x2 equal to alpha, x5 equal to beta. Okay, and then you can write the infinitely many solutions. Okay, that is very, very simple. Understood? So I think I need not to tell you that how to write that, or if you want to write, so you can take here, take x2 equal to alpha and alpha 1 you can say, and x5 equal to alpha 2. Okay, or beta you can take, right? So from here then you can find x4 equal to minus 1 by 2 alpha 2, and x3 equal to 4 minus 4 alpha 2, right? And x1 equal to 9 minus, okay, 9 minus 2 alpha 1, okay, and you can calculate everything, right? So minus 9.5 alpha 2, right? You can get, okay. Now what is the job? You have got x1, you have got x2, you have got x3, you have got x4, x5. Now you have to separate out, right? So you can write here simply the x1, x2, x3, x4, x5, right? Now the constant part is going to give you the particular solution, right? So constant part, this will give you 9. x2 does not have any constant part, x3 has constant part 4, x4 has no constant part, and x5 has also, I believe, no, right? So it is 0 0. So 904, okay, this is a constant part plus alpha times alpha 1 times of something, So just you can mention these In the last session only I have discussed, so please keep in mind. So this is alpha 1 times minus 2 1 and all zeros plus alpha 2 equal to, okay, I believe this is fine for everyone. Yes, so let me uh, here alpha 2 you can write this as minus 9.5, 0 minus 4 minus 0.5, and this is 1. Okay, so now the quick check is what? Just take these values, okay, these value of x1, x2, x3 from constant part and from this, and just plug into original equation. You should get you know, you should get what? You should get solutions of this kind: x equal to x particular plus x homogeneous. Okay, so thank you so much for today. We'll meet in the next session tomorrow only. Okay, or today itself we can meet also, depending upon the time, right? So keep learning and let me know how was this session and whether you are able to apply the concept we have discussed, okay, in the class. Thank you so much for today. So we'll meet again, and from tomorrow we are going to start control system.